Yeah, in the next step, we do now a more complex example. So this is a new example. So we connect now two of these low-pass voltage dividers, low-pass filters. So this was our first circuit. Now we connect a second RC low-pass filter. And I will show you, and I think then you can see that this method works independent of the complexity of your system. The strategy is always the same. Let's call this resistor R1, capacitance 1 is C1, this is R2, this is C2. Again, I want to assume that the output current is 0, so this voltage U2 at the output is not a load for my RC system. There is an input voltage U1, and you see we have now a similar situation, but now with two RC elements internally. So we can say again we need equations. The question is how many equations we need. I will give you an equation or an information so that you can find enough information, enough equations. This is U1 as input, U2 is output, the same. The starting point is the frame of my signal block diagram should be similar to my previous example. I have an output voltage U2 and a source voltage U1 at the input, and I want to have a signal block diagram where U2 is a response. That is the sense of a low-pass filter second order, that this voltage is the filtered voltage of U1. Okay, at least I need one equation to connect both. One equation is always necessary. Why do I need more? Because in our equation system sometimes additional unknowns are coming up. For example, we have work with an internal current I1 through R1. Again, then we will have a second current I2, and if this is 0, unloaded output, we know this I2 is flowing through C2. So we can write this. But how large is the current through C1? We can at once apply the node rule, or we can write the node rule in an equation. We can say, okay, we call this current I3. Then again, this voltage is I1 times R1, this voltage is I2 times R2. Here we have the current named through C2, and the voltage over C2 is named, so we can write the capacitance equation of this, but the capacitance equation of this cannot be written. We have to assume that the voltage over C1 is unknown, so I call this UC. It's a voltage over C1. Now I count additional unknowns. Additional unknowns. This is I1 number 1, UC number 2, I3 number 3, I2 number 4, and the rest is input output. So we have 4 additional unknowns, number of necessary equations is 1 plus this unknown 4. one we need to connect U2 with U1, at least one is almost necessary, and for each additional unknown we need an additional equation, so we need 5 equations. So we have to look into our system and look for 5 physical rules we can express as an equation, and if we have 5 rules, 5 equations, then we can convert into a signal block diagram. Now, list of equations. We can start with the capacitance equation. I think the Ohm's law we can directly integrate in our equations, but the capacitance equation of both capacitors can be written as individual equations. You can say UC, yeah, the output of a capacitor, where is it? The output UC here, UC is 1 over Cp times I. So expressed with voltage is UC is 1 over PC index 1 times current through this capacitor is I3. Then we have U2 is 1 over PC2 times I. Sorry, UC down here we have to write I3. So I3. This is the current through C2 is I2. The current through C1 is I3. Then we have a node rule here. You can say, okay, I3 is flowing out is I1 flowing in minus I2. Node rule at this node here. This node. And then we need 2 equations more. We have a network with elements C's and R's. So we of course then can write down the mesh rules or the loop rules of the Kirchhoff's law. So the voltage in a loop, the sum of the voltage must be 0. This expressed in the first loop is U1 is this voltage plus this voltage. This is I1 times R1, voltage over R1, plus UC, voltage over C1. This is the first loop rule, and we have a second loop where we can write down UC is I2 times R2, so voltage here, plus U2. Then we have third loop rule over the complete input-output line, but note we need only 5 equations. If we have 6 equations, we have 1 equation too much. And we know, maybe you can remember in the lecture of talking, viewer lecture of talking about Kirchhoff's laws, we here in this have only 2 independent loop rules. The third loop rule over U1, U2 is dependent on the both written equations. So then we have an equation which has no more information. So we have now 5 equations. Say 1, 2, 3, 4, 5. And we now go back to our system. U2 is the output, U1 is the input. I think I should make it a little bit larger. We don't need the circuit anymore. I shift this to this position and make now a larger gap, because we have to fill now 5 equations into this gap, so we need some place. And the strategy is now the same. First, count unknowns, calculate the number of equations, fill equations, and now we convert these equations into a signal block diagram, starting always from the output line, looking for an equation which contains U2, which we can solve to U2 and then draw it. if we go through the equations, the first equation is not usable, second equation is possible, third has no u2, cannot be used, fourth has no u2, cannot be used, but you see equation number 5 also can be used to get a picture for u2. You can start with number 2 or number 5. It's your decision. There is no both decisions are correct and independent, and you can decide what you want. I'm lazy because this is already solved to u2. I can directly draw equation 2. So the first step is used for u2, and the drawing is u2 is 1 over pc, and note what I have told you about the replacement of a capacitor with this way. I2 is the input. You should know that 1 over p is an integrator, and in simulation systems this is much better than a differentiator. Okay, without less problems. Integrator, of course you can simulate a differentiator, but then there could be some problems. I will explain later. Okay, now I can mark with a red arrow the second equation. I should never use the second equation again, but I want to show you what happens if you, in spite of my information, do this. You forget, you go now drink a coffee, come 10 minutes later back, you have forgotten which equation you have used. You have an open input I2. Now you look for an equation which contains I2. You see this equation is possible, this equation is possible, but this equation is also possible. What happens if you now use equation 2, not do this? So I now solve equation 2 in respect to I2. This is P times C2 times U2. The drawing of this is very simple. The drawing of this is I block with PC2 as a function. Then you have an input U2, and U2 is available as an output. I connect now this, and you see now there is no open input. U1 is hanging in the air. You have no chance to connect this, because how you can now connect this isolated block with any input. So if you do this, you get you don't get any solution. This is wrong. Wrong. So now do this. So never use an equation again, then this happens. So I have to wipe this out, and we have to do other solutions. Here's I2, I2, and I have to select an equation here which contains I2. This could be equation 3 or equation 5. That's our decision. I take equation 3, better, better, equation 3, solved. I need I2 as an input here, so I have to solve this in the way that I have I2 as an output. I2 on the left side positive is I1 minus I3. So this is a summing point, and I1 is input positive and I3 is input negative, and a negative input can be marked with a negative sign at this branch. So equation number 3 is used in that way. I mark equation 3 with a mark, so never use this equation again. And now I have open input I1 and open input I2. So I can now continue with the next equations. For example, I1 could be used with this equation, I2 with this equation. then you see the open input can be solved with this equation. So this is the order you will see step by step, slowly. I use now equation number 4, solving to I1. I1 is UC on the left side with negative sign and divided by 1 over R1. 1 over R1 times U1 minus UC. Okay, this is equation 4, solve to I1, because I want to fill now a part here in my signal block diagram which has I1 as an output. You see this is an block function with 1 over R1 as a constant function, and the input is U1 minus UC. Input summing point, U1 positive, UC negative. So now I have U1 connected to my signal block diagram, but there are still 2 open inputs, and signal block diagram is only then ready if internal signals not anymore are open inputs. So we use now a 4th equation, one for UC as an input and one for I2 as UC as an output and I2 as an output. I2 it can only used here. Now be careful. UC, I need an equation for UC and I2. UC has 2 possibilities, this equation or that. I2 has only 1 possibility, this remaining equation. If I now use this equation for UC, then there is not an equation anymore for U2. So here I have no decision. I need for I2, this equation is the only possibility. So equation 5, in black please, equation 5 is used for I2. So I solve equation 5 for I2. This is 1 over R2 times UC minus U2. So I2 is the output of a block function with the function 1 over R2, and the input of this summing point is UC, open input UC with a positive sign UC, and on the other hand the second input is U2 with a negative sign. U2 is available as output. I connect directly my summing point with U2, no problem. And UC here is an open input. Here is also UC as an open input, doesn't matter. One output can be connected to any other number of open inputs. That is not a real problem. So I can now mark the 5th equation with my marker, and for UC I have only 1 chance, that is equation 1, and this is already solved to UC. So where is I3? Oops, da stimmt was nicht. There is a mistake. I3. I just check. This summing point equation is I2 is I1 minus I3. I1 minus this is I3. Oh, no, I have made a mistake. Oh, sorry, I stopped here and look for my mistake. Okay, attention, error. Attention, I've made an error. I have made an error. It could happen also to me. It could happen that I make something wrong. If you follow my drawings, then note the error is following I2. I use this equation, and I2 is I1 minus I3. I2 is I1 minus I3, and here the error is this is, sorry, not I2 but I3. Oh, I ask for please understanding. Then of course this is wrong, this is not used. I1 is okay, but this is I3. Sorry for this, I3, and the I2 equation is also not necessary. Nonsense, gone. Sorry for this. Yeah, it happens. I2, so this mark also must be wiped out, and I use now an I3 color, an equation which delivers I3, and the only thing is I3 is coming out of this equation. Yeah, equation 1. Equation 1 can be used for I3. Only way, there's no other equation which contains I3, so I must use now I1 to produce I3. I3 is UC times PC1. So, sorry, yeah, you can see. Also, I make errors, C1, and the input here is UC. Two inputs UC is no problem, but of course now I have to mark this, and UC now is delivered with equation 5, and this is already solved to UC, so I can now use equation 5 to get UC. Equation 5 is using I2 is available and U2 is available. So what I can do is to produce IC is UC is I2 times R2. I go, oh, not in red, sorry. Not red. I want to have black. Junction point, block function, R2. Output is I2 times R2. Now I have to add U2. I take U2 to the summing point, and the output of this summing point is UC. So I can use this UC for this input, and I can use UC using for that input. And now you see any open input is now closed. I have a connection from U1 to U2. So this is the signal block diagram of this circuit using these 5 equations. One possible solution. Out of I don't know how many possible solutions. For example, if you have started with this loop rule and this loop rule, then you get totally different signal block diagram, which if you have made no error, which is correct. If you use this loop and the total loop, you get again other versions. If you use this with another order, I have to mark this, with another order, you get other signal block diagrams. In the paper CRT scripts, the paper which is also available in the Moodle course, page, I looked at page 10 is this example. On page 10 you can find different solution. Page 10 for another version. Same, I think the same equations, but other order of solving this signal block diagram drawing. Okay, so far I think In the next step, I want to show you not an electrical circuit to set up a block diagram. I want to use a mechanical example to set up a block diagram. But this I want to do in the next exam, the next video.